So
Yes.
I don't know if you are going to put like that sensor where when the tank is full, it's gonna sense and there cannot be more water into the tank.
We avoid overflow.
Yeah, the overflow. How do you avoid the overflow?
That's a must to install a flow switch to make it fully automatic.
That is
a flow switch.
a flow switch.
Yeah, such that whenever the water fills to the tank, it will stop the pump until the next time you draw out the water from the tank, so that the pump should wake up and refill what you emptied. Yeah. The reason for drawing too much power, the pump is straining. It's straining. So whenever the motor is straining, meaning there is some load onto the motor. Maybe the pump is clogged or it has jacked. But in this scenario, we rule out the issue of the pump jacking because we had done an additional wire gauze to prevent gravel from getting into the pump, ingress of gravel. Therefore, the only suspect here is instability in power. So when the power was too low, current rises. It will also deflect overall on the other hand, meaning it was false alarm. So it is caused by instabilities of power. Yeah. However, that is not the scenario in solar. Because in solar we get variable voltages from the sun. So in case the voltage is varying, or what we are seeing from the sun is varying, you expect also the speed.
You said that cable is for
The electrode sensor.
electrode sensor.
Yeah.
What is the electrode sensor used for?
Electrode sensor is used to control the level of water
Yes.
in the borehole.
It controls the level of the water in the borehole.
Yeah.
The level of water in the borehole.
So whenever the water, the level of water recedes below the threshold, it will shut down the pump, and the controller will wait until the predefined delay for the pump to wake up again and start pumping,
Very good.
thus preventing dry running of the pump.
Very good. So you said it is electric sensor.
Yeah,
So you install along with the pump.
it's installed along the pump
Yes.
and slightly above the pump.
Or slightly above the pump.
Yeah.
So you said what could be the threshold?
At least 1 meter
1 meter from
Yes.
the pump.
from the pump.
Good.
Depending on the recharge rate of the borehole,
Yes.
if the borehole is recharging fast, you do at least 1 meter. But if it is recharging slowly, you do as much as 9 meters.
9 meters.
Yes.
Hey. Wonderful.
Yeah.
What of how will you control if the tank is the overflow of the tank?
The overflow of a tank, you also use a second sensor, but different from the well probe.
Good.
The conventional flow switch, such that it will control the high level, which is the tank now,
Yes.
such that whenever the tank fills, it will just stop the pump to avoid overflowing.
So automatically, so there's no need of. At times the plumbers use what they normally use,
The ball valves.
ball valves. So
The ball valves
yes.
and gate valves and the rest are not advisable to use on submersible pumps. Otherwise, the pump will be damaged. The impellers will collapse, thus damaging the pump. Or else,
Yes, or else.
the pump will stop and indicates overload, meaning frequent overloading of the pump compromises the lifespan of the motor.
Good.
Or you'll get frequent damages in the pipes. The joints might open if the pump is delivering high pressure. So
Yes.
you might end up damaging your pipeline, damaging your valves, and damaging the pump too. Therefore, you get premature damages and premature performances in your pumping system.
So the sensor to the sensor to control the overflow of the tank is the best.
Yeah. In most cases, depending on the controller, most controllers use a flow switch, but advanced controllers use a sensor called switch type.
Yes.
Yeah, some are 3 probes, some are 4 probes, all. Some are compact, such a way that you use the conventional flow switches.
Yes.
Yeah.
This is an example of submersible pump. We have got varieties of submersible pumps depending on the borehole, the discharge, and the content of the borehole, and the usage. The pump has got almost 3 parts. That is, this is the motor part, this is the pump part, this is the header, yes, or adapter set that connects to the pipes. These are special pipes, UPVC pipes, 1.25 inch. There's a cable, this submersible cable, submersible cable. This is a joint, the joint, so we call it the splicing kit. The splicing kit, it connects the submersible cable and the surface cable. Surface cable is that cable that is appearing on the surface on the earth. This submersible cable is submerged into water. So how this pump runs, the power is connected to the motor, and this motor make this pump to run so that it can push water content to the pipe, the outside or the tank. And this pump, it is stainless, where it's difficult for it to rust. It's cylindrical, it's around 4 inch in diameter, 4 inch in the diameter. And you find that when it's running, it needs maintenance, where at times you find that the soil particles may log in, so it needs maybe after every some period, maybe 1 year or after 6 months, you need some maintenance of this pump. Also, there are other parts like the control panel, the AVS, automatic voltage switch, that it's connected with this pump so that control the currents or the flow of the current. So the pump depends on the voltage, or the voltage depends on the content of the borehole. So this borehole is around 600 feet, and we want to test this borehole so that if it can discharge the water, we take the data. Also, we shall take the water samples for the battle test.